So can we break Algodoo? That's a good question. So just a quick little video to see if we can get a, what I'm calling the Lewis drift. Boom. So Lewis drift is boom, 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 boom. 3 identical bodies. Okay, that's 4. I mean, 4 is fine. Okay, and then you take a chain. Boom. Right, and then another chain. Okay, boom. Oop, see, you gotta check it, make sure. All right, so a chain. Ooh, boom, and a chain. Boom. Is that good? Yeah. Okay, so. Okay. Velocities, freeze. Oh, still didn't freeze, but that's all that tension. Velocities, freeze, freeze. Okay. Okay. So now we want to take these. Right? Let's give it a tail. Okay. Nothing's moving. And now we want to take these. Put you on here. Make you go faster. Motor. Fast as you can. Hard as you can. Okay. Axles. 1, 2, 3. Toggle. Okay, better. Okay, so boom, nothing's moving. 1. Okay, good. Everything's free. 2. 1, 2. Okay. Let's let everything speed up. Now, the only problem with this setup is the chain is pretty heavy compared to the balls. And it's not really a problem. If you made the balls as heavy as the chain, it would be fine. It's just, it's hard to get this thing to kind of kick out with such a heavy chain when it's just disproportional. Weights matter. But let me turn it off. Okay. As well as spinning, it can't really jump out of its position, I don't think. Oh, well, that's got to be stopped. Okay. So now, good, okay. Lovely, lovely. Let's see what it's doing now. Momentum. Okay, angular momentum. Oh, look, there won't be anything. So everybody's just turned, everybody one chunk. Okay, turn it off. And boom. Boom. Hit the screen. Okay. Now I expand the system out. Okay, and I stop it. So all I was doing was spinning this wheel, to make it stretch out. So now, watch what happens. Oh. Oh. Huh. And this is what you do when you watch paint dry. Okay. Let's see that doing anything. Turn it back on, turn that off, and boom. Okay, so now we're spinning again. We're going to stretch everything out. Okay. And then I'm going to hit stop, which is going to contract everything again. Bring it all back in. So 3. Ooh, I like that. I like that. Man, this is not easy to do. It does work. I'm telling you, I gotta get all the sizes the same. Because it's just not going to do anything. So we're just going to make it the material everybody the same weight. So we're just going to put it at 1 kilogram, um, which is fine. I want to put a lot of friction between everything, just because friction is what we're using to offset the system. So I want all those links just by causing as much heat as possible, and let's make them bounce off of one another as much as possible. So there we go. So now we've changed the system, right? Clearly, it wasn't moving anywhere out of its frame of reference. Let's pause that and let's hit it again. Oh, 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 oh. What happened? Oh, slow down. Slow down. Oh. Okay. So now we got to go the other way. I think I might be stuck in a spin. Maybe it don't work. Oh, frustrating. Trying to stop it from spinning. Seems futile. You're going in the wrong direction. Ooh. Okay. I think we're good. Okay. Sometimes you can do it, and sometimes it takes. I mean, I just don't know how to figure out when to hit it, because that's not it. I still ain't got it. Boom. All right. Well, that might do it. No. Let's see. Huh. I like that friction though. There it goes. No. Yeah, that's out of. We did it. It is gone. Give it time. It's a drift, people. This isn't rocketry. I mean, it is, but it isn't. So when it comes back around, okay, see, it's. We're gonna put it here, and next go round, it'll probably smack into it. It should start getting farther and farther away. I don't know, maybe. It's a drift. A drift. Yeah, see? Farther and farther away. And you can see it's moving away. I mean, come on. Goodbye. Sorry it took so long. But you see, it does work. And if you get the proportions right and you hit the excuse me, you hit the um, you hit the angles right, it works, much faster than this. But you'll see, it'll just eventually fly off the screen. Which you shouldn't be doing. Right? So either this Algodoo program is wrong, which doubtful. Excuse me. Woo. So either this program is wrong or my math is right. So I just want to kind of go back over um, the post that you want to see. Uh, let's see, it would be this one. So this is the Lewis drift. Tells you about the math, how to get into it. It starts with talking about the gyroscope, gyroscopic progression and blah blah blah. So we set up the system. And this math here is really, I mean, it's math obviously, but it's describing the system, and there's still more you have to do. I mean, obviously you're going to have to go. I mean, this is not fun, but oh, there it is. You have to look at basically the Lagrangian of every link on this thing, which is what this is doing. So if this was an error in the program, um, like a floating point error or something, you wouldn't be able to do this consistently. This would only be uh, present from time to time. But this isn't a floating point error. This is a physics error. This is an equational error that because this program is using the Lagrangian physics to move from one point to the next. So this is actually right. It's drifting, which it should not be doing, obviously. Um, uh, but if you look at the reason why it does, and this goes into like some pretty advanced concepts like Stokes drift and that kind of thing. So I do explain it, but you do have to um, do some more work, obviously. I mean, this is a good approximation, but you can't really. Let's see. Yeah, so like I said, that's a good approximation. And this one here, this I just validated the proof by working backwards. So we look at this drift, right? We see that that's drifting, right? We know that's drifting, right? See it going off the screen. Um, let's see, wait, closer and closer. Let's just make sure it's drifting. Yeah, see that's definitely drifting. So we notice the drifting, right? And you can now notice the drifting too. So you can build this same thing. You literally just watched how I did it, right? So you build the same thing, and you have to play with it. You have to kind of learn how to do it. And I've been doing it for a while, and not just with Algodoo, but um, with let's see, with the Python. So I've got a bunch of different uh, tests here using different physics, you know, programs. I'll put a link to this in my, thing as well. Let's see, where's a good one? Um, oh, there's some that you just won't understand. Um, um, I mean, there's the ones that are don't work are great. Epic failure. Yeah, like yeah. So not even sure what that was, but you can see, I'm this. Oh, this is on water. We're trying to move on water. It did not work. Um, but some of them do work. Let's see. Yeah, that did not go well. Ooh, goodbye. So yeah, so that's why I use Algodoo because it's 2D and you don't have to get as you know it's not as hard to set up. This is hard to set up. Like you know, but you can see here, like I'm able to achieve like this is a ratcheting. This would be I guess technically called the Lewis Ratchet, but it's these are just little hops. Um, Yeah, see, so I mean, raised floppy space knockers, right? So you can see, like, this is done in different physics programs. This is Python. So yeah, can I make it do anything I want it to do? Sure, sure. But you can also copy all the program, put it into your own Python program, and boom, fix all of my math and find out why it's doing what it's not supposed to be doing. Does that make sense? All right, well, good luck.